Okay, so I guess we are live. Let's see if YouTube agrees with that. Yeah, seems okay. So yeah, okay. I was planning to do a live stream to share my work, and since this COVID thing is going to take a while, why not share something on a sort of regular basis. It can be that the audio is not synced with the video because this video is from my phone and it's streaming over the network, so probably the frame rate is not so good and the audio might not be in sync. And the idea is to share a bit of the development on a project I'm working on. Last year I made a schistoscope, which is for schistosomiasis, which is a tropical disease over 250 million people. And the treatment is rather difficult, so we wanted to see if we can make it more simple. And to make this diagnostic available on the locations in rural Africa. More background about it is here, so if you Google Schistoscope, then you should be able to find some information. Now we're planning on making a new prototype, and that's the development of Schistoscope 3.0. And yeah, I just got in some laser cutted parts, so I want to see if it fits and how this would work. Maybe you find it useful, maybe you have some useful feedback, so hopefully then together with that we can make it into an awesome project. The first thing though is to see if I can fix this a bit more. I want to see if I can add another camera, a proper USB webcam. So I used to have a laptop, but then it broke, and now it looks something like this, and it doesn't have a webcam anymore. So I first want to see if I can take the webcam out of the old casing and see if it's possible to make it into a USB webcam. No exact idea how, but yeah, let's see. And then later we will dig into the Schistoscope project. So I have a overhead camera here, which should also be streaming something, and that runs on battery now, so I don't know how long it will last. It will turn off at some point and then it's gone. Maybe I can restart it, but let's see. From now on I will mostly be working there, and let's see if I can find the old place. Yeah, so see you over there. Maybe I can turn it around like this a bit. Okay, maybe the audio is not gonna work perfectly, but let's hope and stick with it. Oh, cool. First comments are rolling in, so that's good. And yeah, seems that we're live. If you have any problems, let us know in the chat, then I can see if I can fix it. So let's see. Let's give you a better view on this. So I'll go to overhead only. That's better. these are the parts from my previous laptop. Here you can see the keyboards, casing, and the screen. But together with the screen, out also came a camera. So this was the webcam used with my laptop. I think it's still usable, and it seems that it has 4 connections. So I want to see if I can use it as a USB webcam. I'm not going to use anything else anymore, so I can just clip it up here and put this aside. So let's see what cables come out of this. Okay, it's more than 4. And yeah, I remember seeing a video on USB webcams a while ago from these laptops. So I think it was my DIY first. Guy from, I think, Australia or New Zealand. He makes these DIY videos. So if this doesn't work out, I will check his video and see if it's possible to redo the steps that he took. Let me just quickly reply. Okay, I think we're back. I'm not sure, but I restarted OBS. I limited the frame rate, and I guess it's still working. So let's see for how long, but this is promising. At least it's something. Okay. So as I was saying, or trying to say, is that not everything is easy and works the first time. Still trying to peel off this metallic tape. I think they use it often because it's well conductive and also heat conducting. Not only electricity, ground plating, but making sure that the camera doesn't get too warm. So as you can see here, here's the camera in the middle. There's some silicon chips, and then here there's a connector to the cable of the display. And from here on I will just here at the bottom you can see the color of the cables. So you have red, blue, white, black, in orange. Would be nice if they would use color codes, and then often red is positive, black is ground, and the other two would be data lines. So we could check that. Well, background is not. So let's measure continuity. If it beeps, then it's conducting. Let's see. Yeah. And then the idea is to place this little fella here and see if it's possible to measure any of the ground planes. Oh, I'm not in view. No, maybe I am. So one is just touching the ground, and then with the other ones, I will try to see if either of them is connected. So the last pin is connected, second to last. Okay. So if I pull this out again, oh sorry if my hair is in the way. Oops. Okay. So that is not what I was thinking or hoping. So the last two on this line are going through to the ground. So here I'm touching the ground, and then probably this is difficult to see. And the others do not. So that would mean that this red or blue wire is ground, which is kind of annoying because it's not the black cable, so it's not as straightforward as I would expect. And then maybe we can trace the line of the LED here, because that would need power, and it doesn't interfere with the data lines. So maybe a long shot, but maybe worth it. But then again, probably there's a transistor turning it on. So that's the ground plane that I was touching on, one side of the LED. Well, it seems that we're still online, so that's good. Yeah, it's also good to check. Okay, so the black and red wire are from the microphone, so these ones we don't have to use. No, I clip them off to not make a mistake later. And then the red and blue lines were, I'm not sure if you can see this. The red and blue lines were ground, and these are also separated here. And then you have this twisted pair, which to me would indicate data line. Often they twist it so there's less interference. And then there would be orange left for positive. So positive on one side, and then red and blue for negative, and then these twisted wires for data in and data out. Now to see which one is data in and out, I am not sure. But yeah, we can see. I should have a connector here for USB. That would be something like this. Maybe some more cables. And let me check if I can find the wiring for the data lines. Yeah, so I don't know from the top of my mind how it's connected, so why not connect it? Why not check if it can do it together? So I will be switching back to the desktop view, and let's see YouTube. DIY perks USB webcam. Yeah, this was the video I saw. Oh, easy, sorry for the loud audio. Yes, advertising, oh cool.
So as I mentioned earlier, one of the ways you can acquire these webcams.
Yeah, I know.
To wire them up. You may need to solder them to some fairly the data, and they're almost all not into unbeatable.
Epic, people mode.
Is the ground connection, as there are almost always screw
Did that?
No. But wires, which are always the data connection, as that's how USB cables would use interference.
Yes.
On the data.
That's what I told.
So you'll need to take a guess. If a USB device to find is the positive connection, and a relatively reliable way of discovering which one it is to look for a small transistor-like component on the board, which is actually a power regulator. It might be anywhere, and there may be more than one span of wires, as this will be the positive connection. One of the contacts will also connect directly to ground, so don't get confused and test it more than once. So So if all goes well, we can do this.
Epic. Okay, let's head back to the overhead view. Overhead. Okay. So what we have is this goes in here, in here. Okay. So power converter. It's often one of the bigger chips. So there's this is a big chip with a lot of pins. That's to control more complex things. Here's a small chip. I guess this is maybe even storage or flash. And then here could be the power controller that this guy was talking about. It says KS8FA. So yeah, let's check on that. People mode. So the middle pin of that goes to ground. And here we can also strip our wires. Rather thin wires. I thought there would be a better explanation about the data in and data out cables to recognize. But yeah, I guess it's just trial and error. I would say the white is for data, let me see, data in. But who knows? So I think the orange cable is positive. So let's check with one side on orange. Cool. Okay, yeah, let's solder it up and see if it does anything. USB input. Plus, minus, plus, minus. And you have and this is plus. Okay, so if you look at a USB connector, then it's plus, minus, plus, minus. This one is normal plus, this one is normal minus, and the other one are for the data. So this connector on the left side goes to plus. My laptop is still making a lot of noise, so I guess we're still streaming. Okay, this side is still plus. Yeah, I know you're still on. I'm sorry if my hair is in the way. I can't go to the hairdresser now, so that's one. And I think the fourth cable will definitely be minus, which is blue. So blue. And with the minus, it's not that much of a problem if it touches anything of the other um, casing of the metal, because yeah, it's ground. And then I said white is data in, or that's what I was thinking. So let's go next to the orange. And then the black, go next to that. Let's see if I can strip that a bit more. These are absolutely tiny lines. Yeah. Let's hold this a little bit better. Okay. What I can still do is turn this back on. People mode. Yeah, that really is in contact. So I think I can add this one to the ground as well. Okay, let's see. The white cable is not making an ideal connection. So I'm going to add a little bit of solder to this. Okay. Now, a good way to test these things is with something like this, which is a USB isolator. So it has a physical isolation between one side and the other. So if it arcs or something, it wouldn't destroy the whole laptop, hopefully. So let's see. Let's first check if I'm still sort of online. Seems good, so that's nice. And let's see if all works. Check the USB connection one more time. So I have the connector here. This side is plus. Oh, no way. Oh no. Like this. Orange is on that side. Yeah. So let's see. Cables are still connected. Here I have the webcam. Here I have the isolator. Maybe it's cool to hopefully be able to film this. If the live stream ends here, then you know why. If it doesn't, then hopefully we have an extra camera. All the cables are still connected. Everything seems good. In OBS, let's head to the main view and see if there's a update. As soon as I connect this. USB device not detected. So that's not too bad. We can probably fix that. So I was absolutely wrong. And the white and black wires should be the other way around. Which luckily is not too difficult. Let's give that a second try. Might need this. Okay, here goes nothing. Setting up a device. USB 2.0 HD webcam. Epic. Let's see if we can edit within OBS. Device is ready to use. Video capture device. Okay. And it's working. Ha! Nice. Okay. Let's add it here. New face. See if it's possible to turn. Yeah, cool. And we just made ourselves a webcam. Okay, cool. And that should solve the problem of the syncing the audio and the video. So this should be up to date at any point in time. As you might be able to see, I'm using the soldering stand to place this. And let's be a bit careful with the cable now. Better get a good shot like that. Okay. And let's turn it back on transform clockwise. Yes. Cool. Okay, let's change that for this one, because this one is quite laggy. So let's delete this one, put this one here for you, and now we can actually go to place this back here. Take this out. We can continue with doing what we came to do, which is the development of the Schistoscope. I don't have a really long cable on the newly made webcam, so sorry if it doesn't, if the angle is a bit weird, but bear with me for this time. Okay, so we can cross some things off our list. Introduction, getting the webcam, soldering the USB connector, and doing the configuration in OBS, which solves this one. And then maybe it's good to first explain a bit, laser cut, see if it fits, and then assemble as much as we can. So I did this project half a year ago, and now we're developing a new version, which is this one. And I'm super new to Fusion 260, so I basically don't know anything, but it seems like a nice program. And this is what we came up for now. So the whole new product is built around a belly case, which is often used in heavy industry to transport sensitive sensors or heavy material. So belly case, and very rugged, can handle a lot of impact, often come filled with foam. You can adjust it, easy to carry, and strong and durable, which is important in Africa. So yeah, they're quite standard. So that's what the whole case is built around. And then the idea is still same with the previous prototype, to have a Raspberry Pi and a power bank and a camera module and be able to see some samples. What makes sense? So basically what you see here is the design for now. There's sort of a top plate here that covers all the electronics and makes it easy to clean. You can see the big cutout here. This is a possibility to add a screen, touch screen, to interface the Raspberry Pi if that's handy. And what you also see is a plate here, and this will be the sample tray. So the idea is to turn off the diffuser, turn off the rubber seal, and see if we can make the top plate 100%. Basically what you see here is there's a sample tray where the sample itself is put on. So this is the sample with the filter on it, where there's a possibility that there are schistosomiasis eggs, and this sample tray can move up and down in the Z direction. So basically in this direction, that's why you see the sliders here, and here there will be a screw, and this needs to move because if you turn off the sample at the sample tray, you can see the camera module. So here you can see the camera module with some 3D printed parts around it, and you can already see some sliders and motors. And this is basically just like a scanner from back in the old days, where you would have an A4 paper, you would put it on top, and then the scanner would do its thing. Let's see if I can ground this. Yes. The scanner would do its thing and move the scanning line, and then it would scan the paper. Same principle here. You have one opening where the sample tray is put on, and then the camera module can move around to be able to take a lot of pictures of the sample itself. So the sample is here, the camera moves around it to take the pictures, and it needs to move in the Z direction, as I said, here and here, because it needs to be able to focus. And the X and Y movement is done by two sliders and two motors. So underneath these top plates you can see better understanding of what's inside. I can also turn off the case itself. And then you can see some standoffs on the sides, some sliders for the sample tray, a motor for the Z direction, and an X and Y motors plus sliders. And then there's the camera module here with the connector on this side, and there's a reversed lens on top of here. Raspberry Pi is put here, so it should be a bit to the side, and then there's a power bank and some more cables. And from the sample tray there is a rubber seal that goes on top that makes it possible to have some distance between the diffuser and the sample itself, and that closes off all the light. And then on top there will be a LED light source to shine light through the sample to be able to take a good sharp picture. So here there's still a cover that needs to be developed, and I'm still thinking of how to connect wires to the LED from the Raspberry Pi in order to turn on and off the LED. So this can either be with a cable running down alongside with the Z axis, or maybe it should be with some magnets. I don't know what would be the best situation. This is just for now a first prototype. We're using a Raspberry Pi 4, nice, a lot of computing power. And if we turn back the top plate, so here we basically have the design that goes into the casing. Relatively straightforward, a lot of laser cutted parts, and then later some more 3D printed parts will be added. Bottom plates also 100%, and yeah, this is just a sandwich with all the components in between, and then underneath there's still 20mm room to wire some cables onto the end of the box. So together with the box it looks like this, and analysis, a cross section would look, cross section is gone. Okay, let's make a new cross section. Section analysis. This side should be good. Why not show it? And then from the side it looks something like this. So you have the standoffs here, top plate, bottom plate, some room at the bottom to wire cables, and this still needs to be fine-tuned, the distance between the box and the laser cut plate. And then yeah, there's still some room here on top to add some buttons to control, start the program, start scanning, turn on and off the Pi, maybe some indicator lights, just some simple things, but that's for later. And the parts that you see here that I wanted to laser cut are now laser cut. So I was thinking to have a look for that on the overhead camera and to see if they fit together and if it all works as designed in the computer. Because often you realize that if you design it in a computer it might look nice, but actually making it can be a little bit more difficult than just a nice 3D model. So let's see if I can head back over to the overhead camera, and this one can go, yes, and see if I can add the video capture device here as well. Okay. Oh, let's copy it from here. Overhead, yes, that's better. Okay. Well, actually, for the next stream, I promise I will put a longer cable so you can see better either overhead or from my computer side to there. And I will also see if I can fix a longer audio cable so the microphone can reach all the way to the desktop. And for now, yeah, let's see if we can add the 3D printed, no, laser cut parts to the box. Yeah. And how are the streaming? Still going well. Nice, epic. Okay. So if we zoom out now here, then we should be able to have a bit more overview of the never leave your soldering iron on the table, especially not at night. Burns down the whole place. But I'm lazy. Sorry. If you're wondering, well, wait, maybe this is better. If you're wondering what the mask is on the side, I'm also doing a project to make a connector between a scuba diving mask and a filter. So this can be used in hospitals in order to mask yourself, protection from the eyes and both the breathing. They're now doing testing on air tightness and usage. We already tested in the hospital itself and seems promising. But more on that at a later point in time, I hope. Well, I hope it's not necessary, but let's see. These are one of the boxes, and this is how they come. Often they add this foam on the inside to be able to adjust it to your needs. So you can pluck out the middle and put in your products. But we don't only want to ship things in there, we also want to use the box itself. So the foam goes to the side for now. And then I have the top and the bottom plates, laser cut, and some more of these and these, and then some components which are laying here. Well, slider, camera module with some 3D prints. This is one of the XY motors. This would be a shield that would go on top of the Raspberry Pi to control everything and to keep everything organized. Some standoffs, some connectors, and we have some more accessories. Let's see how we can make this view a bit nice. Because sorry, cable really isn't so long. The best I can do for now is this. Hopefully you will forgive me and at a later point of time be able to add a longer cable to this camera so you can see more. This can move a bit here. Let me know if the audio is too low. Actually, now that I'm thinking, you can also do a bit more of the building on my desk itself here, so you will be able to see more and the audio will also be better. Yeah, let's do that. Let's see if I can unplug this here and be able to plug it back in here. Properties. Yeah, nice. Okay. Let's see if we can add it here. Here. Okay, and now we just need to turn it around. Or maybe not. Sorry. And transform the lady. Yes. Okay. And add the other camera with a tripod. Let's see if I can move this to here. Camera is quite warm, so I wouldn't be surprised if it cuts out at some point. Okay. Oh, sorry. So yeah, let's see. Box itself. Here we have the 3D printed laser cut parts. And then some electronics and these. And the box itself, can I also put it here? Would that be annoying? Not too much. It's cool. Okay, so this is all for the sample side. Let's first start with the main top and bottom plate. Should be like this, I think. And this is then the top one. So the idea is to have 4 of these kind of standoffs. Maybe, I don't know if this makes it any sharper. Uh, 4 of these 20mm standoffs at the bottom. These ones. So they would go here, and then on all the 4 sides, and on top of that 3 more standoffs, which totals to 50mm. So 20, 20, and then 10. So these can be screwed in here. This one goes here. This one goes here and here. And then we have a 4th one here. And then in the end, these standoffs would be mounted within the case itself to ensure that it's fit tight with the box, and you can still take off the bottom plate. Next off would be mounting the Raspberry Pi. Same procedure basically with the standoffs. So let's see if I can find some and mount them on there. They gave me loads of boxes with screws and bolts and nuts and standoffs, hopefully. So let's see. Okay. Standoffs. Let's see what makes sense. I have some more by myself. These boxes used to house all my Lego when I was a kid, but I guess now I'm just grown up and I changed the Lego for something a bit more technical. So I kind of like these small standoffs. So I have some of these cute little standoffs, black nylon, that I think would fit in quite well there. I bet you once I turn around the laser cut part, everything is gonna fall out, but let's see if I can handle them. So all of these inserts are quite standard in the industry. They're used everywhere. Only 2 fell out. So they should be quite easy to get, or you can make them into a kit, and often they are from metal, but you can also get them in nylon just to prevent conductivity, but often the place where it's put into is non-conductive, so even if I would use metal here, it would still be mounted to the PMMA, so it wouldn't conduct anything, so it's okay. But these standoffs seem to fit nicely in here. Okay, so that's where it's possible to mount the Pi. And then let me see, entry. Here I have some nice bolts for the Pi to bolt onto, and probably it's better to. I now have a Raspberry Pi 3 laying here, but since we are using the 4, it would be better to actually use a 4. So let me get that. Oh. So here we have a Model 4, 4 gigabytes. If you buy an micro SD card, then make sure to take care of what kind of micro SD card you buy. Because the thing is, the Raspberry Pi writes all of its logs while using the camera or the computer itself to the SD card. And these SD cards were never developed to exchange constant data. They were made for cameras. So you take a picture, you write the data to the SD card, and then it stores it there. But not like going back and forth multiple times a second. So often what you see is that these SD cards, they fail after a certain amount of time because they're not used to this. By now they sort of realized that they should make other SD cards. So they now have this SD card with a marking A2 or A1, and that stands for application. And these are more robust for reading and writing data multiple times a second. So this would be the Pi here, and then screwed down on these standoffs. Oh yeah, stupid thing which I still don't really get, but somehow the holes of the Raspberry are 2.75 millimeters. I guess they are made for M2.5, but seriously, nobody's using M2.5. So always when you try to put an M3 bolt in there, it never fits. But I did find a solution for that. And the solution itself comes in the shape of a 3mm drill. Oh, whoa, easy. Easy, Jerry, easy. So Second try. Drill. Maybe you know this drill. I used it in, or actually I built it in another video. I found it in the trash because the batteries were dead. But with the lithium ion, it works like a charm. And the thing is, you don't have to press really hard or anything, because the holes are already rather big. And then the last one. And then, all of a sudden, your Raspberry Pi does fit. Also, if you are able to find 2.5mm standoffs, sure, use 2.5. So the thing is, you can drill quite a bit out because they have these yellow circles around it, and that is just the fiberglass material without any silk screening or without any conductive padding, and that's just a safety margin from basically the Raspberry Pi Foundation, where they say like, yeah, you can do whatever with this part. So with these standoffs, the Pi looks something like this. And I left enough space on this side to still be able to remove the SD card and flash another one if needed. And then one more. And there's room to put cables underneath here. So now this is sturdy, and then you can place your desired head on top. Let me see if we are still, still working. So I pre-installed these standoffs here, which is not really necessary because it now has the other screws. So once you have your board ready, you can place it on top, and that makes it possible to connect all the different components on there. And then the next thing would be to add some sort of power supply. This can be any type of power bank, and we will still look into what is the best possibility, because there's multiple different options. I guess the best thing is to have one where you can do where you can charge and discharge at the same time, because then you can have this sort of as a backup battery. This Xiaomi power bank does have it. I think the other two don't have it, so for now I would prefer this one. And then, oh, there goes the camera. Let's see if we can fix that. Change battery. Okay. the battery. Need to restart the application. Which should now be back. Yeah, look at that. Nice. That wasn't too bad. Okay. So, after the after the Raspberry Pi, the power bank, and once we have solidified which power bank to use, we can make a more permanent connection. For now, I would just 3D print something that is able to mount on these 4 holes. Then we go to the XY motors. So these are able to be put here, and then another one goes on top. Let me see if I can find another one. Here I have another one. So this one goes on top here, and then again on top of that goes the camera module. So then we already have a lot of the development done. And then what is left to do is have a Z motor. Let me see if I can find one of these somewhere. No Z motor. It's somewhere, but I cannot find it at the moment. Z motor basically goes here. I have 4 mounting holes for that, and that would be able to make it go up. And then from there on, we have the sliders, which go in here, and then the top plate, basically. So this is roughly how the top plate looks like. Then again, 4 connectors to connect the top plate to the to connect the top plate to the standoffs, like this. 1, 2, 3, and number 4. If you connect these bolts always, well, it's best to do it in a diagonal path. So first one side, the other side, and then the other diagonal. And also make sure to first put them on loosely. So don't tighten them all the way straight from the beginning. And only later, so now there's still room for play. Only later fully tighten them down. And then start from where you began. Like this, and that should make quite a solid fit. Yeah. To have the top and the bottom connected, which is also necessary because you want the X and Y table here to be parallel with this face, which is then again parallel to the sample tray. So that's the one that's up next. This is the sample tray. It goes on like this. As you can see, quite a bit of play, but that's because I made these holes 11 millimeters instead of the 8 from the sliders. Because with that, it is possible to add like these nylon bushings, I think they're called, and that would enable it to slide more freely and to have less play on these. So here you can see I have 3 layers of the laser cutted parts and the nylon bushings, so that makes it sure that it's absolutely straight and makes the angle of the sample tray perpendicular to the sliders. So then these fit in here, and from there you have the a rubber ring, and let's see if we can find a sample itself. Should be a box with samples. So a sample would look something like this, just a glass slide with the sample on top. There's plenty of room here to be able to look at this sample. Only thing is that the sample needs to be placed with downward facing so the camera can see it instead of the filter. So that's the main downside of having the camera on the bottom. For understanding purposes, I will now take off this part so you can actually see what would be happening. So it's just a clear plastic piece. The camera module would be facing upwards like this, and then this would go into the bearings like so, and then the sample would be placed here. So we can make small indicators for how the sample should be placed. Maybe it's also good to zoom in a bit here. To give you a bit better understanding. This is how it looks now. So you have the whole sample tray, which will be one part. Okay, this is more something like this. You have the camera sensor here, and here you have the sliders, and then this would be placed on top like so, and then on this side the Z-axis motor will push it upwards so it can focus. Sample would be placed here facing downwards, and then we would have, this is all still very development, but a rubber seal so that the diffuser, which is this part, would go on top of it like this, and that makes it possible to have some distance between the diffuser and the sample, which was required. And then the LED will be on top here and will shine the light through the diffuser onto the sample, onto the camera. And now only thing that is left to do, one more thing which is maybe nice to show and to see if it would actually fit. That is to see if we can add the screen. There it is. So maybe zoom out a bit more again. I have bought a screen. So this screen can be added to the Pi and like that. See if it fits. If it fits, it sits. Okay, yeah, like this. Yes, nice. Where you are able to interface the Raspberry Pi if required. You can also make a more basic version without the screen. And from there you could stop the program. But we can also add more buttons here on the base. And basically the only thing for now for me is that's left to do is to see if it fits within the orange box. So let's get these standards out of the way and this camera module, and hopefully we can put this up in one piece. So this would go this. Oh yeah, the sliders will go out. Is that a problem? No. So it would go like this basically. There goes the screen. Let's save the screen for now. Okay. Well, it seems like this also fits. So this is how it would look like in practice. See if we can put the screen back in place. Sort of. For now, this should be able to do it. So what you would have is you open the box. There's a sample tray here. This way you would put the sample in. You would close the lid, and then it would turn on the light, make the adjustments with the X and Y direction with the camera, and it would be able to diagnose the sensor, the sample. So yeah, everything contained in one simple box. And I think from here I should be able to do some more of the development and do some testing with the X and Y table, because there seems to be still a bit of play on there. So for now, let's take it out of the box again. Which is good to note that there's still a bit of play here and here, but maybe this is good to fill with rubber, so that if something drops or if something falls, that it's not directly hard plastic to hard plastic, but that it's able to absorb some of this energy. So both in the X and Y direction there's a little bit of play, but not too much. It still looks like one quite solid cover plate. And the height seems to be good. I can still close the lid. And that's about all for now. So we can take this out, which could also be useful for maintenance, to be able to swap parts out. Put this on the side. So this is the bare model. Take out the screen like this. Yeah. So the sample goes like this. So for now, quite pleased with the results. Everything seems to fit. There's still place to put cables in between. I made a hole here for also other cables or something needs to be changed if you need to access that. And yeah, let's see what we can change on the 3D model to be able to make this better. An ultimate test, of course, would be to see it running, although at the moment that's not totally feasible. One thing I forgot to mention is that we might want to add some connector like this. These are like panel mounts. Maybe this was better. Panel mount micro USB connectors. So that would make it possible to place it somewhere within here, and then have a cable go in here, so you don't have to fiddle within here to connect all the parts together. And also since it is quite a concealed space within here, it is good to see if we can find maybe some short cables, because if you have like the 1 meter cables, then it easily adds up. So if I were to connect the power and stuff, let's see. Dollars will keep on turning. So this would be an adapter for the micro HDMI to normal HDMI. And then a short HDMI cable itself. Yeah, basically, I guess the learning from this will be don't underestimate the size that the cables take, because if you see, often you don't model them because they're supposedly flexible, but here you can already see that if we put a normal HDMI cable, then there's almost no room for the power bank, and then we still need a micro USB cable for power and touch, so that would go here, and then the USB-C cable for powering. And And then another panel mount connector for the, oh, not this one. Oh, come on. A straight micro USB connector to the panel mount connector. Later we can also add these kind of fans to add for cooling if necessary, and we can add push buttons to start and stop programs. So this would go like this. These ones can go. There's nothing connected to the shield at the moment, so that is able to be taken out. So even here you already see that the HDMI cable itself is sticking out. So for this we will need to find either a straight angle HDMI connector or maybe just a different cable in general. I have another one here, but I don't think it's any shorter. No. So don't underestimate the power of cables. Also, something that I really like to use is gaffer tape. And gaffer tape is so much better than normal duct tape, because these things are used in all the concert halls, podia, theaters. And the great thing about it is that it's at least as strong. The webbing inside is much finer, so you don't get the wrinkles. And the best thing by far is that it doesn't leave any glue residue. So where the other ones often leave some of the glue. Are we back? Think so. Okay, so my internet dropped, like the whole router rebooted, but I think I am back at it and it seems to be working. Yeah, let's see how it's going now. Where did we stop? Don't underestimate the power, the annoyingness of cables. And I just made a stupid mistake where I didn't connect the HDMI cable to the Raspberry Pi. So let's try to still do that. Some sort of way, like that. And click. And let's see if we can run a Raspberry Pi from a power bank with a screen without at the moment the camera module, but that's okay. And yeah, maybe see if it works at all. SD card is inserted, so let's power it on. Seems to be booting. There's some LEDs on this side to indicate that the Pi is turning on. And I see no signal on the monitor itself, which is sort of good because that means that it does get power. And then the only thing is there already a screen from the Pi, or is it still booting? So let's wait a couple of seconds for that to be sure that it's booted. No signal. Let's see if I can. Maybe I can check. Let me know if you see anything on the screen. I can disconnect this one, connect it to the second monitor. Seems better, but no change in the Pi itself. Oh, that's good. Oh, look at that. Seems that we have a screen. So let's place it back in its original orientation. Seems a bit stretched. Do we have a keyboard? Yes. And a connector. Okay. Always the wrong side, the wrong way around. How do I turn this on? Like this. Yes, it's working. So we have a Pi from a power bank. Let's see. Cause we can change Pi configuration. Display. Yeah, it's the Pi 4 and it has a separate screen configuration menu. Which takes a while to load. But in the meantime, I might be able to change this into Raspberry Pi configuration. Oh yeah. Interface. Localization. There used to be a place, there you go, where it's possible to change the size of the apparent. Set default for small screen. No, medium screen. Large screen. Yeah. Sudo raspi config. Yeah. Raspi. Well, dash config. Advanced option. Resolution. And then 1200 by 600, I think the screen is. Advanced option. Let's do a reboot. See if the screen is any better. Okay, seems less stretched. Preference, screen configuration, configure. No. Orientation. Right. Oh, no, cancel. Let's see if this works. Left. Okay. Okay. This is better. Look at that. Oh, yeah. Touchscreen is still moved. Yeah, this looks good. Sample tray here. And be able to put on the sample, have the film, rubber ring. Camera module underneath. Okay, Googling schistosomiasis is not the most fun thing to do. The only thing I wanted to see is a sample. Urine sample. Yes. So, in an ideal world, we would be able to see these kind of eggs with a sample. That will be something like this epidermis. and then inside a big orange box. So yeah, that's the whole idea. Everything seems to work. Cables need to go somewhere, but we can figure something. And then let's check one more thing. The Raspberry Pi always has an indication of if it's in under power mode, which I haven't seen so far, so that's good. The only thing I want to check is to see if I can charge it while the Raspberry Pi is powered. So charge the power bank basically, and we would do that through this connector that would be on the panel on the front. So let's see. So as soon as I connect it, it does start to charge. The only downside is that it gives a low voltage indicator. Kind of interested about that, but let's see how it works in the future. From here we can use all the different examples and do all the config. So it shows all files, everything seems to work perfectly. Nice. So that's good. Shut down. Shut down. And then the light needs to go on top here. And let's disconnect this. And then power also disconnects. Oh, now it boots again. Sorry, Pi. And let's head back over to our Fusion 360 model. General screen. And let's see what we can do. Yes, I know that you're on. Yeah. Shut down. This time for good. Cool. So next up will be how to mount the LED. I can make a to-do list. Explain design, laser cut test, assemble things. Yes. So from now on it would be how to power LED plus wiring, magnets, and then another thing is cover around LED. And do we want users to take it off totally, or should it be some sort of hinge? Because if you take it off, then the wiring has a problem. If it's a hinge, then you need to either 3D print a hinge, which already sounds terrible, but well, it's doable, or use an off-the-shelf hinge. And we still need to make a mount for the Z-axis motor. Make a mount for the power bank and mount the X motor to base plate, mount Y motor to X motor, and what else? Test the how is it called, sample tray, movement, no wait, test if sample tray movement is level. What else? Finish PCB, order PCB, assemble PCB, test PCB. Test distance between sample and diffuser. Test distance between diffuser and LED. So for now, these sliders are still quite loose within the laser cut part, so there's quite some play on this. These ones. So I want to see if I can laser cut, instead of 11mm precisely, something slightly smaller so it fits in there tightly. Because also while laser cutting you cut away material, so it's not weird that there's a little bit of play, but it just needs to fine tune. And then we need to add buttons to top plate, and I think fix stand offs to bottom case, seal top plate with side of the case. I guess next micro USB panel mount connector to top plate. I was thinking to maybe laser cut the stand offs as well, So this is a thought I have to, instead of use these stand-ups, to use a piece of laser cutted material. So that you would clamp the laser cut material in between, which has the upside that you're using material that you're already using, and that it's support for a long width, so that makes it possible to not zag in the middle, because now it still flexes. The only downside it has is that it doesn't fix it to the top plate. So now we put screws and we can just lift the top plate, and that lifts everything. But that would require it to still add these fasteners on the top. Still thinking on what's the best way for that, because I think this sagging in the middle is in the end unacceptable. So maybe still have something in between here that lifts it here to make sure that it's always 50 millimeters apart. Yeah. In the end, we also want to see if we can use different sliders, because the sliders that we do have, I find that there's quite a lot of play on it. So that results in less accuracy. And what I did find is, in my younger years, I like to take apart computers, and I found this, I think it's CD drive, which has sliders more to the sides, and that made it possible to move this block with less wobble than this piece. So maybe either use exactly these things, because they have a solid base plate with built connectors, or use a similar design and find something online with better sliders. So yeah, let's see how that would look like on the computer. This should disappear. Yeah, here you can see the sliders quite close to each other, so of course it's more prone to or it has lower tolerance, higher tolerance. There's more play on it, so yeah. Sample tray, slider, sample user, Now the next thing will be how to connect this motor, this slider to this slider, because it needs to be, let's take this. Let's take this part one away. Put it in the box where it fits and where it belongs. Well, where it doesn't fit, because the HDMI cable is sticking out. How to connect this part to this part. So I want to have the motors on one side. A design consideration will be where to mount it on this side, because the thing is that you can either mount it in the middle of the geometry, where it intuitively makes sense, but you could also mount it in the middle center of the mass, which is more towards the motor, so around here, because the motor has more mass, so mounting it somewhere here would make more sense than, because then you distribute the load, than mounting it in the middle of the geometry. So that will be something like this. We do know the dimensions. The only thing is, am I gonna put these small brass inserts in here, which would make it easy to screw something from the top in there? Or am I gonna use a middle plate where I mounted the middle plate to here and then the plate itself to there? I think either way I need to add the inserts to here, and in an ideal world I would like to maybe see if I can mount it in between here, so have screws in here and here, so you don't have an extra middle plate which takes up more room. Only question remains, is that possible? To make it easy for myself, there's 5 holes here. I modeled them and also put them here, so I can use this as a template for drilling in here, so I know that it has the same spacing as here. Let's see how that looks in the computer. So within the camera module, if I open that here, everything still seems to stream, so that's good. This is also good. It's a bit of a mess here. If I do isolate this, you see the 5 holes. Let's see, which are those? Edit sketch. 1903, 5.13, 2.2. Still a bit surprised by these numbers. I don't know if they really, if those are really the exact measurements, but that's what it said online. Let's see if we use that. Okay, I'm planning to stream for half an hour more, so around 5 I will close down and start thinking what to make for dinner. Should still have quite some vegetables, so don't need to go to the supermarket, which is a lot less fun nowadays. Normally I would just stroll around in the supermarket, and now they want you to be efficient and stay away from everyone, so yeah, doesn't make sense, but it's less fun. Yeah. So this is the camera module that you can also see modeled there. I printed it in the weekend with the Prusa i3. I just borrowed it from school. Seems to be a super nice printer. I was surprised that it can print such nice details, 2.2 millimeter holes. And if you have a look here, maybe I can. Is it possible? I don't know if you can see, but let's get some light on that. Yes, so you can still see some individual lines. So the initial Z height of the first layer is not perfect. Still need to dial in the details a bit. But if you see like gaps in your first layer, that means it should be either squeezed a bit more, or the first layer should be a bit thinner. Yeah, so basically the same model here as you see on the computer as on the webcam. And the question is this the same as here? Yeah, it seems pretty much the same. Something that can help is have something in one hole and check the fit with the others. Yeah. So it should be mounted at a 90-degree angle. So the 5 holes like this should be like this. The only thing is, if you place it exactly like this, you see that 2 of the holes are covered by the lead screw and the metal plating underneath. So I can either do it off center, which is again not ideal, or I need to make some sort of adapter plate, or just use 2 of the screws. And to be honest, I would kind of be up for trying just 2 screws and then see if we can maybe add epoxy resin to really glue it together, because most plate will definitely still be on this blocks, so I cannot really change anything about that. Yeah, let's just drill 2 holes here and here. Let's get some marker and connect. If you watch Adam Savage, his channel, which is the guy from Mythbusters, he makes a lot of cool stuff. But he was recently talking about these pens, carpenter pens. They have a long pointy bit, and from there it makes it super easy to go through holes and to be able to still put the one dot at the place where you actually want to drill or make something. I think the 2.2 millimeter is a bit too much to ask. Yeah. But that still super nice pen. So let's see if we can find the middle of the mass. Which is funnily right around here. So put the middle hole here in the middle of the center of the mass, and then make a point here and here to be able to drill. So since the pen cannot fit all the way through, I can still make a small mark to know where the block should go. And then so place the template here, make some light drills just to indicate where it should be drilled, and then yeah, from there sometimes you can keep using the template because that helps to keep the drill at a 90-degree angle. So that's one hole, and now the other. Yeah. One thing that I can do to make sure that it fits is to screw this down, the template, because that makes it possible to not move this anymore. So M2, another one, make this go through. So one side goes here. So now when I drill the other hole, I'm absolutely sure that this one will fit. It does take a bit of extra work, but in the end, in my opinion, it's often worth it because you don't spend a lot of useless time drilling out holes again and making it bigger. So now I have one here and I can drill the other hole. Okay. Perfect. Yes. Now I can untighten it again. And then I still need to make the holes in this slider bigger, because those will get an insert for the 2mm one I'm making now here. So the only thing is that it is quite close to the lead screw. So I hope it doesn't touch to the bolt on there. But it should be good. Should be able to put the bolt there. Yeah, this is the camera module. This goes like this, this goes like this, this goes like this. So it should be these two holes. This one, this one, and this one. And then I'm gonna use the 3mm drill again. If I can still find it. Yes. Since the sliders already have holes in them, you just need to let the drill be able to find its way, and then it's easy to make a straight downward facing hole. And then let's see if we can find some M2 inserts. 4mm should be good. These two. There are two, different ways on how to put these insert in. On the one hand, I do like just heating it with a lighter, because then you can still push it in with the thread. You're sure that no plastic goes inside. And the other upside is that you can more easily make it face upward. But for now, I'm gonna use the soldering iron just to heat it up quickly, because it's also nylon, so it's a bit more heat resistant. Maybe I can even put this a bit closer here. To give a bit of an insight, use the freaking stand if you have it. Don't put it on your table. Cherry. I'm still not sure if these things have a top and a bottom side. They look quite similar on both ways, but I'm never sure. So best thing is just to put it in one go. It's hot. Seems good. Then you get something like this, which I will show on the webcam as well. So here you can see, I will make it a bit bigger, the inserts inside of the model that would be able to mount these on here. So it's 4 millimeters in here, then it's another 4 millimeters here. So in total M to 8 millimeters sounds good. Let's get 2 of these. Yeah, it's 6 millimeters, but it should be good. So let's see. So now the big question is, will it fit? And I'm not sure. I heard a click, which is sort of good. I hope it can catch the thread. Remember that one time where I said don't screw everything down? It's also important to keep yourself to it. Because I screwed the one side down before screwing down this side. But I don't think they will both fit at the moment. Also, they didn't really give the exact hex screws. No, I don't think this one fits. So what are we gonna do? Make a hole a bit bigger. Sorry for the rather boring stream. Not much happening. Well, it's very detailed, and I don't have the correct cameras to show you this amount of details. Let's use the 2mm drill. To make these slightly wider. Yeah, this seems to work better. Still cannot promise anything, but the head of this screw is bolt. It's not good. This one. Yes. This is better. Uh-oh. There went my DSLR again. Yes. Luckily, I don't have to do this every stream. Once it's connected, it's connected. Not my smartest move. Yeah, now it fits, but now I stripped out all the thread. Which does mean that the fit was quite precise. Well, actually, it's not moving that much. I wouldn't be disappointed. So the play between this seems quite minimal. It's way more on this. So I wouldn't be disappointed gluing this down. And it seems that this can still move. So that's good. And now let's see if we can it's possible to put some inserts in here to mount this on here. Yeah. Let's bring this to the soldering iron together with some inserts. Here. No. Yes. Here. Two of these. I seem to be very static the last days. I don't know what it is, but every time I touch metal, it doesn't seem to end good for me. So that's with the inserts in. Now let's see if we can also add some screws to that. Best direction would be like this. To be honest, they're not the best screws I have here. The heads seem either the inbox itself is not correct, or the heads seem to have too much of a tolerance on it, which makes it difficult to screw down. Let's see if I can still make it tight enough. Ooh, I have an idea. Yes, yes. There might be better screws. 4, 6. This is great. Oh yeah. Found another box. Oh, so much better. They do have a bigger hat, but that makes it possible why it's a lot tighter tolerance. Because in the end, gaps within this add up to a sensor that is not parallel to the sample. Yeah. Look at that. And it even fits. So here we have something that looks remarkably a lot like finish sketch. Which looks a lot like this. So that's cool. The only thing is that this is mounted 90 degrees at a 90-degree angle, I think. So oh, wait. Oh, I was thinking to put it the other way around. And let's have a side-by-side view. So now I did put one of the motors sort of the wrong way around. Would have been better if it was the other way, flipped. But for now, I don't think that gives much of a problem. This one is at the front. Yeah, still has the same amount of travel. It can hold it like this. Can travel in this direction. Can travel in this direction. So that should be able to be mounted on the bottom plate. So if we come back to this design, and open this. I can take off the top. I can take off quite some cables. And we can have a look here. So that would look something like that. Then we can take some tape if we want. So here I have some double-sided tape, and I'll stick it at the bottom of this, and that makes it possible to temporarily, at least, glue it on this. Where it would look something like this, and then cable 1 goes here, cable 2 goes there. Uh-oh. Still moves on one screw. So this would be the maximum play. And if we have a look with the top plates installed, we do see something interesting where either the cables has to bend quite a bit here, or we need to swap the motor around. Yeah, it was designed to be swapped around because now the movement of the camera is outside of the gear. It's like this. Difficult to say, probably. Here you can see the camera, and if it's here it can still move. So now it can still move there, and it cannot move all the way here. So this should be changed. other than that, looks good. My corona. I was wondering what happens with this. It is touching. So to solve that, yeah. No, it's not touching. And the lens can see the microscope side. Like this. Cool. And I'll move it a bit more towards here. This is the diffuser. Rubber seal. Sample placed upside down. Sample tray. Camera. Motors. Papa! Cool. Cool, cool, cool. Yeah. Changing this. Oh, wait, can. I thought it would be more complex. Maybe see if I can also find other screws for these. Yeah, so I would say I got this set of screws from Ninjin. Do not buy these. Might be nice, but the heads on these strip out super easily or not accurate. So I wouldn't recommend using them. Be better off just getting something else. Like Pinru. These are much better. Let me see. 4 is too little. This is 6 millimeters. Still too little. And then 8. Yeah, I'm still alive and alive, live and alive, but trying to assemble this XY combination again, and seems a bit more tedious than expected. Sorry. Eh. I would say, to be honest, let's use some double-sided tape, because this doesn't seem to work at all. For now, just for testing. For double-sided tape, you should always try to cut it with a knife and not try to cut it with scissors, because the thing is, it comes in between the blades of the scissors, and getting the glue residue off there is not the nicest thing. Rather difficult. One like this, another one like